There are two chief methods that exchanges use for orchestrating a call. The first is progressive direct dial control. The second is termed common control. Let's look at the progressive method first. Illustrated is a basic two-digit exchange. There are two talking path switches, with many not shown. The subscriber on the left will initiate a call to subscriber 74. The switch has built-in relays to grant dial tone, count the dial pulses, and control the stepping action. A 7 is dialed. A second talking path switch receives the next dialed digit, a 4. The built-in relays control the wiper's rotation. The relays manage other events for this call. When the call completes, the system resets. Progressive control is appealing in its simplicity. However, time is an issue. All switching actions must be completed during and between dialed digits. This is a problem when controlling some switch types and for long-distance calling. Common control relaxes time limits and uses cost-effective shared resources to assist in call establishment. Let's see how this works. First, let's look at the concept of sharing resources among users. An analogy will help, using the office water cooler. The two water coolers here are resources shared in common among all workers, not just these 8. The coolers should meet the typical daily demand for a floor of workers. However, on occasion, a worker may need to wait for a cooler to become free. This is by design, since, on average, the two coolers will meet the expected demand without lines forming. Let's see how this concept relates to telephone systems. Here's a collection of the most essential resources, located in common service pools. These are typically found in a number 5 crossbar exchange. Like the office water cooler, they are replicated to match the workload. A resource is allocated, as needed, during call establishment. Most are active from 0.3 to 10 seconds, depending on the function needed, then freed for another caller. They are primarily constructed using relays. Let's see two shared resources at work. A dial tone marker, shown here, connects a new caller to a dial tone register, here. This is the first phase of call establishment. The register provides dial tone and then records the subscriber's dialed number. The subscriber goes off hook, starting a new call. The line circuit causes the subscriber ID to be sent to the marker. Using the ID, the marker controls the first crossbar switches. Next, it controls the second crossbar switches. The register is seized and provides dial tone. The marker is released, free to service a new caller. In a real system, it's only in use for about 0.4 seconds. Markers are complex, some with up to 1,500 relays. Shown here are only 4 cross points inside 2 large fabrics of many hundreds of switches. Creating the route through the fabrics is a tall order. Its operation is significantly abridged here. Next, the register stores the 4 dialed digits. The register sends the recorded digits to another component, not shown, and the call process continues. The register is returned to the common resource pool. The example just described demonstrated only one phase of call establishment. There are more steps to complete a call, but not explained here. Importantly, the talking path switching action occurs asynchronously from the dialing time. Bottom line, making a call uses common control apparatus momentarily, then returns it to the shared pool. This method proved effective, for many reasons, and was used by different exchange types worldwide for over 60 years.